On July 28, 2023, NASA announced it had awarded Firefly Aerospace of Cedar Park, Texas, a $176.7 million contract to deliver 2 rovers and 3 scientific instruments to the lunar surface. This announcement came just 1 week after Intuitive Machines was awarded a $146.4 million contract to land a rover on the Moon for NASA's Commercial Lunar Payload Services initiative. So, what exactly is Firefly providing, and how does this latest contract differ from Intuitive Machines? The delivery is the first time NASA will use multiple rovers and a variety of stationary instruments to work together on the lunar surface in a collaborative effort with the CSA, Canadian Space Agency, and the University of Bern. It will help us understand the chemical composition of the lunar South Pole region and discover the potential for using resources available in permanently shadowed regions of the Moon. This is great news for our goal to discover if there is water ice at the lunar poles and see if we can harness these resources to sustain human life. But this isn't the first time Firefly has been awarded a contract under the CLPS initiative. Under the new CLPS task order, Firefly is tasked with delivering end-to-end payload services to the lunar surface. The period of performance runs from Tuesday and ends on March 29, 2030. The company's lunar lander is targeted to land at the Moon's South Pole region in 2029. And according to Pulse, author of The Moon in the 21st Century, this would be the first privately built spacecraft to land in the lunar South Pole region. This region has been chosen due to its high albedo or brightness and low gamma-ray emission, suggesting a concentration of hydrogen, a component of water. The abundance of hydrogen and water ice at the lunar poles could have significant implications for future human exploration of the Moon and beyond. Water ice could be used to support human outposts on the Moon, or even provide the fuel necessary to propel future spacecraft on their journey to Mars. This is Firefly's 5th task order award and 4th lunar mission through CLPS. Firefly's first delivery successfully landed on the Moon's near side in March 2025 with 10 NASA payloads. The company's second mission, targeting a launch in 2026, includes a lunar orbit drop-off of a satellite combined with a delivery to the lunar surface on the far side. This makes it the first commercial lander to reach the far side. Firefly's third lunar mission will target landing in the Gruithuisen domes on the near side of the Moon in 2028, delivering 6 experiments to study that enigmatic lunar volcanic terrain. You can learn more about this mission in my video on it. So what will Firefly be doing for NASA with this latest contract? To answer that, let's look at the payloads they're delivering to the lunar surface. In total, there are 5 payloads that will be sent to the Moon, with the majority of them being delivered by the 2 rovers. First up is a little rover called Moon. Now, this may not sound very exciting, but hear me out. Moonranger is an autonomous microver that will explore the lunar surface. We've seen cube rovers deployed on Mars with the Mars Science Laboratory and Perseverance landers, but this little rover will do things that we haven't seen before. While most small planetary rovers focus on one primary science experiment with mobility as an afterthought, Moonranger puts mobility front and center, with its main purpose being to demonstrate autonomous navigation and hazard avoidance in a polar environment. With its complementary science instruments, the mission will map the local geology and search for water ice. It will collect images and telemetry data to help scientists understand the Moon's South Pole better. Its onboard neutron spectrometer system instrument will study hydrogen-bearing volatiles and the composition of lunar regolith or soil. While some aspects of the rover have been designed and built by NASA, the overall platform has been developed by Carnegie Mellon University through their Space Robotics and Intelligent Systems Lab. In fact, it was built by students at the university. According to Dr. Ashwath Ramon, assistant professor at Carnegie Mellon's Robotics Institute and principal investigator for the project, the team took an agile software development approach, leveraging commercial off-the-shelf components and integrating them into a flexible open architecture. This allowed the research team to iterate quickly when requirements changed or when there were lessons learned from testing. Lead development organizations for the rover are NASA Ames Research Center in California's Silicon Valley and Carnegie Mellon University and Astrobotic, both in Pittsburgh. Next up is a stereo cameras for lunar plume surface studies. This instrument will help scientists better understand the plume produced by the lander. as it descends to the surface. Specifically, this instrument will use enhanced stereo imaging photogrammetry, active illumination, and ejecta impact detection sensors to capture the impact of the rocket exhaust plume on lunar regolith as the lander descends on the Moon's surface. The high-resolution stereo images will help predict lunar regolith, erosion, and ejecta characteristics as bigger, heavier spacecraft and hardware are delivered to the Moon near each other in the future. This information will help keep future landers safe from the effects of plumes produced by previous touchdowns. The lead development organization for this instrument is NASA's Langley Research Center in Hampton, Virginia. Also included in the contract is NASA's Laser Retroreflector Array. This will consist of 8 retroreflectors on an aluminum support structure that enables precision laser ranging, a measurement of the distance between the orbiting or landing spacecraft to the reflector on the lander. The array is a passive optical instrument, which functions without power, and will serve as a permanent location marker on the Moon for decades to come. The lead development organization for the LRA is NASA's Goddard Space Flight Center in Greenbelt, Maryland. Moving on to the rovers, we have the CSA rover, which will help scientists better understand the geology of the South Pole region. The CSA rover has several instruments to help with its main objective. It has stereo cameras, a neutron spectrometer, 2 imagers, visible to near-infrared, a radiation microdisc, and a NASA contributor, thermal imaging radiometer, developed by the Applied Physics Laboratory. These instruments will advance our understanding of the physical and chemical properties of the lunar surface, the geological history of the Moon, and potential resources such as water ice. It will also improve our understanding of the environmental challenges that await future astronauts and their life support systems. The rover is being developed in Canada at the University of Alberta with funding from the Canadian Space Agency and contributions from several Canadian universities and companies. The rover will weigh approximately 1.4 tons and measure 2 meters in length, width, and height. The mission will last for 1 year on the surface of the Moon. Lead development organization for this instrument is the CSA. The last instrument is the Laser Ionization Mass Spectrometer, or LIMS. This is a mass spectrometer that will analyze the element and isotope composition of lunar regolith. The instrument will utilize a Firefly-built robotic arm, titanium shovel that will deploy to the lunar surface and support regolith excavation. The system will then funnel the sample into its collection unit and use a pulse laser beam to identify differences in chemistry compared to samples studied in the past, like those collected during the Apollo program. Grain by grain analysis will provide a better understanding of the chemical complexity of the landing site and the surrounding area, offering insights into the evolution of the Moon. Lead development organization for the instrument is the University of Bern in Switzerland, so that is what NASA will be getting with this latest CLPS contract. They'll be receiving 2 rovers and 3 scientific instruments that will help us learn more about the Moon's South Pole region. One of the rovers will map the area, test autonomous driving features and search for water ice, while the other rover will help us better understand the chemical composition of the area. We'll be getting data from a fixed station that will help us better understand the plumes produced by rockets on the lunar surface, which is important for future missions that plan on landing near each other. Also included in the contract is a retroreflector array that will allow us to measure distances to the lander for decades to come. Finally, another instrument will drill down and help us understand the chemical makeup of the soil at the South Pole. If you haven't already, please subscribe and turn on notifications so you don't miss any of my videos. Thank you to my supporters for your continued support.